you go, another proof. And again, you're going to see the process, the same process over and over and over. If you want to prove that something like this, SQ and PR are the same, and you look and see where SQ and PR, they're the left side and the right side. My process is always, okay, if we can prove these two triangles are the same, then all the parts are going to be the same, the corresponding parts. So let's go through that process, and this one will be pretty easy to prove. Step number one is given. What is given is that this angle and this angle are the same, and these two angles are also the same. Step number two, does anybody else see anything that's also true? PS is equal to the PS. Why? Got the same reflexive property of the image. So I'm going to put tick marks there. That's equal to itself. So therefore, the two triangles are equal. And again, be cautious on how you write. Triangle, I'm going to do it like this. I'm going to start here. I'm going to say RSP. The reason I did that is because I went from the one tick mark angle to the two tick mark angles to the none. So somebody tell me what RSP is equal to? CPS. Why? Angle, angle side. That is angle, angle side. Two angles and a non-included side is equal to two angles and a non-included side. Now, can we say, let's be careful, can we say that SQ and PR are the same? Go back to our congruence statement we just wrote. SQ, which is here, is it the same thing as PR? SQ, PR. Yeah, they're the same spot, right? So therefore, we can say SQ must be congruent to PR by what? Good, CP6. I'll tell you what, instead of, let's go through the thought process. Instead of actually proving some of these, let's just go through how we would prove it. It says A is the midpoint of MT. Riley, since A is the midpoint of MT, tell me what's true. Well, I guess we'll throw the proof in the garbage, and we'll just, we'll just make this bigger. A is the midpoint of MT, so Riley, what's true? So therefore, what's the midpoint? A is the middle of MT, so therefore what? MA and AT is the same. Everybody understand that? Hunter, A is the midpoint of SR. So there you go. So somebody tell me, are those two triangles congruent? Colton, they are, but what else are we going to have to say before I can say they're congruent? What else do we know is congruent here? Why? Because those two angles are vertical, therefore we have congruent angles. Since this is true, since I have these three things congruent to these three things, can I now say that these two triangles are the same? Let me write the congruent statement. Triangle MAS is congruent to, let's see, M to A to S. What goes along with that? TA. Okay, tar. Triangle tar. Or triangle tar. Triangle mass is congruent to triangle tar. Now, look what we're trying to prove. The two lines are parallel. That's all. How do we prove two lines are parallel? We've got 5 methods. And I want you to know those. We can either prove that corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent. Same side interior, same side exterior are supplementary. So do you see any alternate interior angles there that might be congruent? M and T. He says angle M is congruent to angle T. How do you know that? Now that the two triangles are congruent, how do I know that M and T are the same? CPCPC. The corresponding parts will be, because look, see where I'm underlined? M and T. Now that those two triangles are the same, are M and T the same? Yes. Are those two lines now parallel? Why are they parallel? Because alternate, there's your parallel lines, here's a transversal, inside, opposite sides. Since alternate interior angles are congruent, then those lines must be parallel. And we'll do the same thing on the others. Instead of going through the proofs, we'll reason through them like that. Here we're given that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, and it's marked there. 1 and 2 are the same, 3 and 4 are the same. And I want to prove the triangle BCE. Let me mark it. Prove that BCE is congruent to DCE. All you're given is that this angle and this angle is the same, and these two angles are the same. This one's a little tough. A little tough. Yeah, it is. Good question. I don't know. There's no way we could prove it. Let me prove that. How can we prove those two triangles? Maybe I'll use some things. See if this helps you. Since CA is congruent to the same, is this big triangle CDA congruent to CBA? And if so, why? This side's congruent to this side, right? So this triangle would be congruent to this triangle by angle side. And now here's your next step. I'll go ahead and move it. Since that's true, do we know that CD is congruent to CB? Okay. You're getting that. We're going to now prove the two small triangles. Why are these two small triangles congruent? Don't they also share a side? What do they share? CE. So therefore, are those two triangles congruent? Triangle DCE would be congruent to triangle DCE by side angle side. So that was a long way around that. We had to prove the two big triangles were congruent, just so we could prove that those two smaller sides were congruent to the small triangles. And then since they share that side by side angle side, those two are congruent to each other as well. Everything that you're given is marked. And we're just wanting to prove that ML is congruent to QL. ML is congruent to QL. This would be a pretty easy proof. Maybe I should give you this one instead. My question, Jagger, are the two triangles congruent? Let's see, is LMN congruent to, are these two congruent? You have two angles, right? And a non-included side, that would be two angles and the sides not between them, so angle, angle, side. By angle, angle, side, yes, those two triangles. You'll see where the side is. Here's the two angles, there's the side not included. So the two triangles are congruent, so help me finish this, Alex. LMN is congruent to what? LQP. Oops, that's an R. Try again. So is ML congruent to QL? Everybody look at the congruent statement. Now that you know they're congruent, why can I say that ML and QL are the same? C, B, C, T, C. Once they're congruent, then everything about them is congruent by C, B, C, T, C. Okay, last one. B is the midpoint of AD. Trace, since B is the midpoint of AD, look at BA and BD. What's going to be true there? B is the middle, then this is the middle. Okay. So what the distance from A to B, Trace? If the distance from A to B is 7, what's the distance from B to B? So therefore AB and BD are equal. That's all I can do. AB, BD are congruent. Now, can we say the two triangles are congruent yet? Everybody look at that. Are the two triangles congruent yet? Uh-uh. Not yet. Where can we go from here? You got parallel lines. Somebody tell me two corresponding angles on this side. Instead of D and B, you can't just use, you can use D, A, B, C, because there's multiple angles there. Those two angles are the same, right? Because when parallel lines are cut by a transversal, or I don't care if you just say parallel lines imply that corresponding angles are going to be congruent. So now, are those two triangles congruent? Good, yes. And Briley, write for me a congruent statement. Triangle ABC is congruent to triangle what? B. Good. And since triangle ABC is congruent to BDE, can I now say, there is a much easier way of doing this. I'm trying to prove that BAC, this angle, I'm trying to prove that that angle is congruent to that angle. Could I say that that's true now by CP? Sure. Somebody tell me the easier way to avoid that. You have an angle equal to an angle, right? You have a second angle equal to a second angle. What's that theorem from? If two angles are the same as two angles, then by the third angle theorem, you're close. By the third angle theorem, is that not always true anyway? I didn't have to go through all that angle, side stuff. I didn't have to do that. I could say since two angles are congruent to two angles by the third angle theorem, we know that BAC has to be congruent to BDE as well.